Once again, welcome to the Actionable Continuous Delivery Metrics webinar. My name is Craig Lewis, and I'm part of the sales team here at ThoughtWorks. Today, Suzie Prince, who is our head of product, and Aravind, who is our GoCD product manager, will be taking us through a webinar. But before we do that, let me just tell you a little bit about ThoughtWorks if you don't know who we are. So ThoughtWorks is a global technology consultancy. We partner with enterprise clients to solve their most complex technical challenges. We were formed in 1993 in Chicago, and in the early 2000s, Martin Fowler, whom some of you will know, joined ThoughtWorks as the chief scientist. Martin was one of the first people to promote continuous delivery as a best practice. And at the same time, or right around then, ThoughtWorks created one of the first continuous integration products, Cruise Control, as open source. In 2006, we formed ThoughtWorks Studios, which is the group you're speaking with today, to bring our developer tooling expertise to the market. One of those products we created was something called Cruise, which was then a newly rewritten continuous delivery product, which we then subsequently rebranded as Go in 2010. And at that point, Jez Humble, who had been the Go product manager, went off and wrote this book called Continuous Delivery, which some of you may have heard about. In 2014, we open sourced GoCD, making the product available for use at no cost. And since then, we have a rich community of contributors and plugins that make GoCD one of the leading products in this space. Just a couple housekeeping notes. Chat in the Zoom webinar is disabled. If you have some questions, please use the Q&A tab that's somewhere near the middle of the bottom of the screen. And at the end of the webinar, we've reserved some time so that Susie and Aravind can answer any questions you might have. If we're not able to answer, if we don't have time, we'll do a follow-up email to everybody. So with that, Susie, I'll turn it over to you.
Okay, thank you, Craig. Before we dive into our content today, I just want to quickly go through our agenda so you know what we'll be covering. In many of the examples, we'll be showing you our continuous delivery tool, GoCD. So at the very start, you'll see a quick note about that. Then we'll define what continuous delivery means to us. We know many of you are familiar with continuous delivery, but in order to ensure that we understand it in the same way, we will review our definition for continuous delivery. Then we'll explain why measuring continuous delivery is valuable to you, followed by what metrics you should gather about your continuous delivery process. And then we'll share some examples that explain what certain continuous delivery metrics reveal to you about your continuous delivery process. And finally, like Craig said, at the end, we'll leave some time for questions.
All right, thank you, Susie. Some of the examples you see will be screenshots from GoCD. As Susie mentioned, it's a free and open source continuous delivery server that we work on at ThoughtWorks.
So apologies, Aravind, I think we're having a hard time hearing you.
Okay, I'll just carry on. And then Aravind, if you're able to restart, just let me know. So I'm just going to redo this slide for everybody so that everybody can understand about GoCD before we get started. So like I said, some of the examples that you'll see will be screenshots from Go, which is a free and open source continuous delivery server that we work on at ThoughtWorks. We also try to show you how metrics can be visualized manually using a spreadsheet or in other tools if you're not using GoCD. So GoCD is not a prerequisite for the information that we're going to share with you today. It's just used as an example. So let's start with our introduction of continuous delivery. As Craig mentioned at the start, Jez Humble is the co-author of the book Continuous Delivery, and we use his definition for continuous delivery in our practice. Continuous delivery is the ability to get changes of all types, including new features, configuration changes, bug fixes, and experiments into production or into the hands of users safely and quickly in a sustainable way. We think it's important to notice that the definition talks about all changes to a software project. This is not just features, but other changes including experiments and configuration changes as well. In practice, a simple CD pipeline can look like this. The material at the beginning, the blue dot, is usually a repository, a source repository, such as Git or SVN. In this webinar, you might hear us refer to this view here as a value stream map or a VSM. That is GoCD's representation of the CD pipeline. In this particular example, the delivery team commits a change and GoCD runs, build, and unit tests. In these tests, if these tests fail, which is shown here in red, the team immediately fixes any problems, and the new version goes further along the CD pipeline. If the tests fell further down again, the team fixes them as quickly as possible. In our example here, you'll also see that we have a piece of the pipeline called the user acceptance, or the UAT. This is meant to model a manual step, which is shown by the dotted line there. In continuous delivery, the team makes a decision when to release. The key is that the software is always in a state that can be given to customers, which is indicated by the green successful points of the pipeline. In comparison, continuous deployment would not have that manual step. A build that passed all automated steps would be automatically deployed to production, such as this. This process happens over and over in the life cycle of an application. And in this webinar, we're going to look at metrics for this process and select which ones to use and why. So why bother measuring your continuous delivery process, and why bother capturing the metrics about it? Let's go through some of the reasons why. There are two reasons why you should gather data about your CD process. The first is that data is an important part of a feedback cycle. If you consider a feedback cycle like build, measure, learn, or even plan, do, check, act, metrics are a way to help you set specific measurable goals. They allow you to direct your activities towards achieving those goals, and ultimately, they help you understand if you are achieving those goals. Feedback is a significant part of the continuous delivery journey, and so your metrics will help you along the way and guide you along that journey. The second reason why metrics are important in understanding continuous delivery is that the specific data values you will gather will be very useful for you in a number of different ways. The first is that they will allow your organization to compare yourself to DevOps benchmarks, such as those provided in things like the State of DevOps surveys. If you want to know how you compare to the highest performing teams, you'll need to understand some metrics about your continuous delivery process in order to do that. Next, the data that you have will allow you to predict your future behavior and allow you to provide more accurate estimates to your business. For example, if you know your cycle time, when you're asked how long something will take to be ready for customers, you can answer that question a lot more accurately if you know your historical behavior. Data will also allow you to estimate the cost or the value of an activity. For example, if you're considering parallelizing some tasks or removing a manual approval step, if you have data about the time these activities took or the occurrence rate, you would be able to calculate how many days you would save by removing them. If you know the cost of your time to your business, you'd even be able to calculate what you save in dollars or the dollars that you generate by doing something. So hopefully you can see that gathering data, gathering metrics about your continuous delivery process clearly allows you to provide additional value to you and your organization. But what should you measure if you decide to measure your continuous delivery process? There are many options on what you could measure about your continuous delivery process. This list here is just a few that we found in CD case studies, DevOps reports, and from our work with development and DevOps teams. You can see that the metrics shown here are very varied: cycle time, escaped defects, production outages, deployment frequency. And we don't suggest that you start by measuring all of them. There are 4 metrics that we recommend you consider starting with, because these generally add value and help organizations improve their continuous delivery processes. These are throughput, cycle time, mean time to recover, or MTTR, and failure rate. Let's define these metrics and show you what they measure. First off is throughput. This is generally a percentage. It is the answer to the question, how often does code reach a certain point in the continuous delivery pipeline? For example, how often do we deploy? But deployment may not be the only point that you care about. So it may be, how often do you push to a staging environment? Or how often do you go to UAT? In this example, we consider production deployment as a significant point in the continuous delivery pipeline that we want to measure. So we are counting the number of times a deployment to production happens versus not happening. In this case, we have 8 instances or 8 opportunities to deploy, and 2 deployments happened. Therefore, we calculate our throughput in this example as 25%. Our next metric is cycle time, and this is a duration, sometimes in days, maybe seconds, maybe minutes. It depends on your organization. And it generally means how long does it take to go from one point to another point in your continuous delivery pipeline. For example, how long does it take to go from code commit to that code running successfully in production? Whereas throughput is the number of times something might happen, cycle time is the cumulative elapsed time it took for that to happen. You may see in the literature, on the internet, in other blogs and references, that cycle time is used interchangeably with the term lead time. And there is a lot of confusion around what these 2 terms mean, if they're the same, if they mean something different. We think that the important thing is that you are clear what you mean. You define what you mean, and you're consistent with your definition and your usage. We suggest you avoid simply saying cycle time without qualifying what that means in the context of your organization and your continuous delivery process. In our example here, we calculate time from a commit, which is shown at the start of a CD pipeline, to when the code commit goes to production, which is shown at the end. In this case, although other points in that pipeline have happened multiple times, it was only after 3 days that the deployment happened. And so that is how we calculate the cycle time for this commit as a cycle time of 3 days. Our next metric is failure rate. This is also a percentage like throughput. What is the percentage of changes that result in a failure? For example, what is the percentage of changes that break builds? Or what is the percentage of deployments that result in a service outage? In this example, we want to measure failure to deploy. So we count pipeline runs that do not result in a deployment. Again, there are 8 pipeline runs there are 6 failures, so our failure rate is 75%. In this specific example, our failure rate is the opposite of our throughput, but that may not always be the case depending on your process. If you have manual approvals, like I showed in our original example, or you're calculating failure rate as a build failure rather than a deployment failure, your failure rate may not simply be the inverse of your throughput. So again, this shows why specifying what you mean by certain metrics is a very important part of this process of gathering metrics. Our final metric that we're going to talk about today is the mean time to recover. It's often abbreviated to MTTR. This is a mean duration, and it means how long does it generally take to fix a failure. For example, how long does it take to fix a broken build, or how long does it take to restore service after a deployment failure? In our example, we're calculating the mean time to recover from a build failure, not a deployment failure. So we want to look at the specific point when a build turned red, it failed, to the point when it became green or succeeded. And we're measuring the time between the failure and the next success. As this is a mean duration, we want to look at multiple occurrences of this failed succeed cycle. In this example, the build failure is immediately fixed in 2 occurrences. So it was easy to calculate our mean times our mean as 2 days, because it was 2 days in both cases. Obviously, that's not always going to be the case. So that's why you measure multiple different occurrences to get your mean time to recover. And the mean time to recover is 2 days. Okay, we've suggested these 4 metrics: throughput, cycle time, mean time to recover, and failure rate, as they can be generally and usefully applied in many different situations. However, in some cases, you will want to apply them more specifically, like I talked about, build failures versus deployment failures. Likewise, what is important to you or your goals of continuous delivery may not be captured by these metrics. It's totally appropriate for you to select different metrics instead of these 4, but let's think about how you should select and which metrics you should select. If you're selecting your own metrics, please be thoughtful about the metrics that you choose and capture. Here are some of the things that you should be wary of when selecting metrics. Be wary of vanity metrics. These are metrics that are easy to measure but provide no value to your organization. A good example of this is sometimes bugs fixed. We will see many organizations tracking bugs or defects and the number of bugs and defects fixed, but with little understanding about what the number of bugs fixed really means to their processes and their customers. I'm not saying don't fix bugs, it's just the value of whether that number actually means anything to you. Be aware of unclear metrics. Be sure to define what you mean, as we did in the previous section, and educate those who are using the metrics what they mean. Be sure to make your metrics visible. We suggest big visible dashboards in your workspaces and regular reports that people read to ensure that the metrics really are used. Avoid insisting that every team use the same metrics if their goals differ, and avoid comparing across teams and creating valueless competition. Be aware of the Hawthorne effect, sometimes called the observer effect. This is when individuals modify their behavior in response to the awareness that they are being observed or measured. We know of a specific organization who started to measure test coverage, and in response, people began writing tests without assertions just to get the test coverage results that they needed. The Hawthorne effect is real, and you'll want to avoid that or be aware that it's a possibility. Finally, avoid gathering data just for the sake of it. Be specific and clear about what is important to you and change only that. If the metrics you're using don't work for you, then change up the metrics rather than just adding more and more. So we've discussed the metrics that you could start measuring and how to select different ones if you want to, but how do you go about this process? How should you start to gather the data? I'm going to run through a quick checklist of how you might do this. First off, we recommend creating a value stream map or a VSM. This is a value stream map of your path to production. We'll show you an example of a VSM created in GoCD shortly, but you can also create this manually using pen and paper or a whiteboard. Secondly, you need to select the metrics that are important to you, and we've discussed the 4 that I suggest, and also how to select your own. Then you need to capture those. Again, you could do this manually using a spreadsheet or in a tool like GoCD, and we'll show you how to do both in the next section. But it's not just about capturing metrics and storing them away. You need to actually review your results. There's no point capturing them without reviewing them, and there's no point reviewing them without sharing them. So remember to make them visible so that everybody can improve. And our last checkpoint is learn. This is basically the plan, do, check, act cycle in action. Use your metrics in a feedback cycle to help you improve.
All right. Thanks, Susie. Let's see if my audio works this time. Let's take a hypothetical scenario and see how metrics can be used to improve your CD workflow. This is an example VSM or value stream map, as Susie called it, that you can see in GoCD. This represents the continuous delivery pipeline. It runs the build and some unit tests, then runs integration tests, smoke tests in parallel, regression tests after that. Finally, there is UAT and production deployment. Let's say that the complaint that the business has told us is that they don't get value very often from all the work that is happening. Let's see how the 4 metrics that Susie talked about can help you understand what's happening. Right? We recommend starting by looking at your throughput. It was the one that is mentioned in the initial complaint anyway. So to figure out whether low throughput is a problem, you'd look at the run frequency of that part of the CD pipeline that you care about. GoCD has a paid analytics plugin, which helps you find a lot of information about CD metrics. Let's take a look at the runs of a specific part of it, say the build and unit test part. Using a chart showing every run of this part of the CD pipeline against the duration it took to finish. The green and red dots signify the final state of the run. Focusing on the run frequency, we can see that it ran over 100 times over the last 30 days. During that same time period, the production pipeline ran less than 20 times. This clearly shows that less than 20% of the runs are reaching production, resulting in a low throughput to production. If you're tracking these manually, or in a spreadsheet, or using tools like Graphite and Grafana, you'll see more failures on the way to production part of the CD pipelines. In this example, when you track and plot the runtimes, you'll see that in the same time period of 5 days, build and unit tests ran about 14 times, and production ran about 6 times. So there's definitely some confirmation that what the business is saying is reasonable. The main signal is that the throughput is low, but there may be many reasons for this. It could be slow running builds, or it could have to do with builds that fail often, or it could have to do with builds, long-lived feature branches or pull requests, which are not merged often. The development team might be working very hard on their branches, but the business won't see value till the changes are deployed often. Metrics such as cycle time, failure time, MTTR will help you understand what may be causing the low throughput and help you resolve the issue. If your problem is that you have work going on in long-lived branches, you can consider feature toggles and trunk-based development. So let's see if we can find out what parts of the CD pipeline are causing a low throughput. In an upcoming version of the GoCD's analytics plugin that I mentioned, you can choose to see details about the cycle time between any 2 points in the GoCD value stream map. In this example, you can see the value stream, and then you can choose to see analytics between the build and unit test pipeline and the production pipeline, for instance. GoCD shows you how long it took, on average, to go between the 2 parts of the value stream. In this screen, you're seeing each run of the CD pipeline or GoCD's VSM, and from the build and unit test part to the production part. It's showing a throughput of 20% and an average cycle time of 33 minutes, including some runs you'd need to scroll down for. You can even drill down into each individual run and see how long each part of the CD pipeline took. In this case, it's showing you wait times and run times towards production. Again, if you're doing this manually or using some other tool, you need to track the start and end time of the different parts and plot them. You would see something like this. In this example, there are some long-running parts of your pipeline shown as the wide bar in regression, and some long delays due to manual approvals. So why does slow cycle time happen? Often, low throughput is caused by a cycle time that is slow. Steps that are slow to complete or require lots of wait time will lead to overall low throughput. So you should focus on the slowest. That is what will give you the most gain. You can convert manual approvals into automated ones by increasing your level of confidence in the tests and automation. You could even rewrite them if possible. Parallelization is another possibility. If you draw or get the value stream map and truly understand the dependencies, you will find opportunities to parallelize. Maybe it is possible to start the slow running tests earlier on in the process, decreasing cycle time in the progress. Yeah. All right, another aspect of reduced value delivered is a high failure rate. In an earlier image from GoCD, we could see that there were many failures at different parts of the value stream. Looking at one of those parts, you can see that it has a high failure rate, in this case, 35%. If you're tracking these manually or in some other system, you look at the failure rates of the parts of the pipeline that you care about. In this example, you see about a 67% failure rate. All right, let's look at high failure rate. Remember that pipeline failures are not inherently bad. They prevented something from failing in production. However, having too many unexpected failures can reduce throughput and reduce delivered value. Common causes that we've seen include flaky tests or tests that are hard to run locally. You could try and fail fast by running high value and fast running tests, bringing them to the front of the pipeline to get feedback faster. Make sure that the test can easily run locally before checking in. However, do not penalize failures. Remember the Hawthorne effect. You don't want your teams to become afraid of checking in changes, right? The final metric that Susie mentioned and that we'll be looking at is MTTR, or mean time to recover. Again, GoCD's analytics plugin shows you the mean time to recover easily enough at different parts of the value stream. It captures the time between a previous failure and the next success and averages it across failures across time. Manually, or in another tool, what you would need to capture are the time of failure and time of success and use that to calculate the mean time to recovery. In this example, there was a failure on day 1 at 10:15 a.m., which was fixed finally at 1:25 p.m. with a recovery time of about 190 minutes. Then there was a failure on day 2, which was fixed later for a recovery time of 400 odd minutes. Taking the mean of those gives you the MTTR. So reasons for MTTR, high MTTR. Slow cycle time also shows up as high MTTR sometimes. If it takes a long time to fix or revert to go through the pipelines, then the mean time to recovery might be high. Other reasons could be that no one cares or failures that are hard to pin down. Effective mechanisms we've seen to combat high MTTR include an unquestioning revert of failing commits or stopping the line. Stopping the line is an effective strategy from the lean world where anyone can cause the assembly line to stop so that problems don't propagate further down the pipeline. New changes can only go in once failures are fixed and root causes identified. You can see that all of these methods help together to understand what's happening. And we also know that we went through a lot of information really quickly. We will be sharing the slide deck soon. And we also have some time for questions coming up, where we can go through this in a little more detail if needed. What you need to remember, though, is that the context of the team or the organization is really important to understand everything that's happening. You need to decide on the right set of metrics to ensure that you improve your delivery process without adversely affecting the behavior and the culture of the people on the team. Thank you.
Thanks, Aravind. Like Aravind just said, we know that we've captured a lot in the short space of time. So before we finish, we want to review some of the main points covered and reiterate the important takeaways for you. First off, metrics are important to set goals, improve your continuous delivery processes, and help predict your future behavior. Be thoughtful about what you measure. We suggest you start with throughput, cycle time, failure rate, and mean time to recover, if you don't have any other specific needs. Once you start looking at your data, look for connections between the metrics. As you saw in our examples, a low throughput may be related to a slow cycle time and/or a high failure rate. So pay attention to multiple metrics to understand more deeply what is happening in your process. Next off, you'll need to understand your context to understand how to improve. Do your teams work in branches, and could this be limiting throughput to production? Have you added lots of new staff, and this is temporarily increasing your cycle time while they get up to speed on your processes? These kind of details will help you make sense of your data and then help you to improve your continuous delivery process. Remember that the whole reason for using metrics is to help you in a feedback cycle. So review, change, and improve your process based on what you've learned from your metrics. Finally, consider using tools like GoCD to help you capture and visualize your data. This will allow you to share your data and give everyone access to the same information, helping you to pinpoint more opportunities to improve. We've provided some additional resources to you, so when you receive your copy of the presentation, make sure to review them and they'll help you learn more about using continuous delivery metrics. And now it's time for our questions. During the Q&A, you'll see a poll appear with 3 simple questions. This poll provides us with feedback about this webinar and will help us to improve. We value your feedback, and so if you could take a couple of seconds to complete that poll and help us get better, that will be really useful for us. All right, so now let's take a look at our questions.
All right. There's one here that I can take. The question is, how do these metrics take into consideration the different sizes or complexity of various changes? It's a good question. Different CD pipelines are completely different. Susie mentioned not comparing between teams. This is also about not comparing between different kinds of changes. Maybe there are changes where there's a long running story or an epic going, and there might be smaller changes that are going in. Everything, in my opinion, comes down to the baseline that you want. You might have a CD pipeline for an application, which which is a small application, which you would expect the changes to be less complicated. You might have a different CD pipeline for another application, which is complicated, which is a monolith, which is a legacy. There could be many, many reasons, and you would expect the complexity of the metrics of that to reflect that. So you shouldn't compare between the two. You would baseline them differently. You would look to see if there are things that you can learn from the metrics. You would baseline them. You would see how you can improve them. Basically, do not try and compare across CD pipelines and their metrics. Use them separately and use separate metrics for separate applications and changes. Okay. Susie, do you want to take anything? Or?
Sure. I can talk about the GoCD being open source. What is the difference between the free version and the paid version? There's, I was going to say there's not much difference between the paid version and the free version. There is, but what I mean to say is that the free version is definitely a complete solution. So it's a complete continuous delivery server that a lot of different organizations use. What we offer in our paid version is we offer paid support. So if you need support using GoCD, you'll have access to our support team and our development team to help you answer questions, talk about your needs, and really offer support with that. And then we also have a number of paid plugins, such as the one that we showed you in the webinar today. That's our analytics plugin. We also offer database plugins and plugins about recoverability. So if you take a look at the enterprise offering on our website, which is gocd.org, you'll be able to see what is offered in the paid version. But if that's not something that you're interested in, I want to be clear that the free version is a complete solution, and you can easily start there before you consider the paid version.
All right. So another question that that we have is, in practice, do people revert a failed build to reduce mean time to recovery? If so, how? Before I answer that, just wanted to mention there is a little Q&A section down there in Zoom, so you can ask questions there. So the question was, in practice, do people revert a failed build to reduce mean time to recovery? If so, how? I have been part of teams where we have reverted a failed build, reverted commits from a failed build automatically. It does happen. I mean, we weren't thinking of it in terms of reducing mean time to recovery. It was basically, okay, something is broken. The change that went in was problematic. So, we're gonna revert it. We used to do that automatically. I've seen people take a quick look and say, okay, this is too big a change and we're going to revert it and try again later. So yeah, it does happen. It definitely does happen. It does take some discipline though, because you then have to figure out how to re-revert it if it's a big merge commit. You have to agree as a team that, okay, your changes are going to get reverted, and that does not mean that it's a problem. It's just that it's just a way of keeping the CD pipeline green and ready for any kind of deployments. Basically, keeping it ready to go all the time. All right. Susie, you next or me?
I was going to leave some of these for you, but I do want to say the first question, how do we extend this capability to add new metrics? I wasn't sure what that means. So if we want to clarify that question, we can, and we'll answer it for you. Maybe we can take the question about Jenkins, Aravind? Sure.
The question is, can GoCD integrate or coexist with Jenkins? Yes. Yes and no. Well, yes, obviously, because they're all tools. They're both generic and they can live together. Why I would ask you to think about it is because there is overlap in some senses between what Jenkins does and GoCD does. Jenkins is a good continuous integration tool. It's based on builds and the way that you can use it pretty well for continuous integration, in my opinion. However, in my opinion, it lacks when it comes to continuous. It comes when it comes to continuous delivery, because the modeling constructs that it allows aren't really perfect for continuous delivery. For example, GoCD has really interesting modeling constructs such as pipelines and value stream maps and so on. Jenkins does have something named similarly using Jenkins pipelines and so on. But if you dig deep into it, you will find that it is not, it's, in my opinion, it is bolted on top of the older Jenkins modeling construct, which is almost simply just builds, which are very simple. We also have a blog post about GoCD and Jenkins where we don't try to compare it feature-wise, but we talk about differences in philosophy and why we think that GoCD is meant for CD, whereas Jenkins works really well with CI. What we've seen is that when people want to convert or when they want to try out GoCD and want to keep Jenkins, they do that using GoCD's APIs so that they can have Jenkins build something and test something using its plugins and reports and so on. And then they could use GoCD's APIs to start off a pipeline, CD pipeline, and then go from there. It's definitely possible. You would want to look at whether you really need two different tools. GoCD can do both CI and CD.
Yeah, and if anybody wants to take a look at the blog post that Aravind mentioned, I believe if you go to gocd.org/Jenkins, you'll find some of the points that he listed out there. And we're also happy to take comments on the blog post and discuss it further.
All right, Susie, you said you're going to answer a question about pushing to source control automatically.
Yes, so I'll read out the question so that everybody understands it, and then I'll answer it. Does every push to source control automatically result in a deployment in production? Put otherwise, is it possible to push a lot of small commits, use the different test steps, unit, smoke, integration, regression without deploying every change to production? Yes, we definitely can do that. GoCD can do that. And that's definitely a choice that you can make within your organization. For us, we define continuous delivery that every commit is tested to see if it can be put in production. So it's a possibility that you can push to production, but we don't consider that every push will automatically go to production. So in that sense, we differ continuous delivery and continuous deployment. And continuous deployment, it would be automatic, but with continuous delivery, it's not. And you're able to do either of those two things with GoCD, and the practices that we suggest is definitely a choice for you.
All right. Another question here is, does GoCD consolidate metrics by product? For example, aggregating metrics from a set of pipelines that compose a product? Yes, so GoCD's analytics plugin is more of a pull-based model. You choose what you want to see. So you say that, okay, these are the pipelines that I care about. And I want to figure out how long it took to go from this part of the pipeline to another. And it also depends a lot on how you've modeled your CD pipelines. So you might have multiple, let's say you have a microservices kind of architecture, and let's say each of those individual components are modeled as separate sets of pipelines or parts of the pipeline. And then maybe everything integrates together using GoCD's fan in and fan out and so on. In the analytics plugin, you can choose one part of that and say how long it did take to go all the way to wherever, a destination part of the pipeline. And that is decided by you, not by GoCD. The reason is that it's really hard to say between teams what they consider as the end of their pipeline. It's not always just the rightmost part of the value stream. For some people, it is in between. And then after that, they have other things such as production metrics, which they capture, or they might have rollback set of tasks and pipelines and so on. So this is why it allows you to choose what starts and what ends. So yeah, it does do that. All right.
Okay. I'm going to take a question, which is about measuring between an idea, so the conception of an idea, to the deployment of an idea. So that's definitely something that a lot of people want to do. And that's sometimes where this confusion that I mentioned around cycle time and lead time comes into play. You're definitely able to capture that manually. Right now with GoCD, we focus on once a code commit is made. So this does not include the idea inception, when the idea really started. We primarily focus on the part of the downstream process from when you commit to when you put into deployment. But like we showed in the webinar, it could be something that you manually capture that you can then use adding on to the pieces that we would capture in GoCD to do that. Is there anything on there, Aravind, about things that people might be able to do to understand the beginning of the process around ideas?
Yeah, it depends. I mean, a lot of the time, idea is a very abstract concept. People consider idea as the time, I've seen people consider idea as the time they put an issue into Jira or GitHub issues, for example, to the time that, that it finished, in quotes, whatever finished means. Essentially, in the Agile methodology, you will be deploying a feature multiple times, the same feature, because you build on top of it, you build a small thin slice maybe of one feature, and then you make more changes to it. You make it, you embellish it a little bit more, make it better towards what you want. And at some point, you might decide this is good enough. So there's not really an end time in that sense. End is whenever you decide, okay, this is good enough. So in my view, if you really want to track the full end-to-end, a lot of it is outside. A lot of it is ideation, which you need to keep track of separately. And then it goes through multiple cycles and you say this is good enough and you would need to track it. So I don't think a tool can do that because not every part of that cycle is tracked. So I would consider doing it manually if you really want the idea to end. All right. So there's a question about what kind of deployment reports, which environment, which version can we pull from GoCD? So GoCD is a general purpose orchestrator. It does not really force you to do certain things, anything in a certain way. So what happens is most of the time, and this is mentioned in the CD book as well, what you want to do is to write small scripts which allow you to do things that you want, and then have a tool such as GoCD or Jenkins or anything that you want to execute those things. That way, all your deployment information about knowledge of how to deploy, what needs to happen, where it happens, all of that is in those scripts. And these tools are just controlling those scripts and passing them the right parameters and so on. So to come to things like reports, GoCD doesn't say, okay, you need to deploy in this environment, you need to have your pipelines in any specific way, all of those things. So most of the time, what I've seen people do is to write simple scripts which use the data that GoCD provides a task, which it provides a lot of information, like a lot of environment variables that you can use, and you can use the APIs to generate information the way that you want. It has quite an open API that you can see at api.gocd.org, and people I've seen generate their own reports. I've seen people use these dashboard monitoring tools like to put up reports on big dashboards. All of that uses either GoCD's feeds or the APIs, which are quite flexible to allow you to do things like this. I've also seen some integration with SonarQube and things like that, which also would do something similar. All right. Do you want to take that question? There is one about adding new metrics, or we can answer it later. It's your choice, Susie.
I'm happy to take a shot. I think that you know more of the specific details than me, but the question is, how do we extend the capability to add new metrics? So during our webinar, we saw metrics built in GoCD, and the person is asking whether we could add new metrics. Can we build plugins? What information does GoCD provide to help you build these plugins? So yes, you can definitely build plugins for GoCD. We have extensive APIs that allow you to pull information out of the GoCD server and allow you to use those in the way that you want. The specific thing that comes to mind in this case is that I've definitely seen people use things like Grafana to create their own metrics dashboards about the data that is captured on their GoCD server about their continuous delivery process. So I would recommend that you, again, go to our website and take a look at our documentation, our developer documentation around how to build plugins. Like I said about Go is open source and free. We definitely value contributions, and the rest of our community would love to see some plugins being built around GoCD. If that's not something that interests you, then that's why we have also built our own analytics plugin. It's based on the knowledge we have around continuous delivery. It's supported by our team, and it's something that we're continuing to improve and build on. So you have multiple different options in terms of gathering metrics yourself, or using the plugins that we can provide to you. Are there other things about building plugins that are prudent to add, Aravind?
Yeah, sure. I mentioned the analytics plugin, and Susie also mentioned it earlier. Because GoCD is open source, they are both, the analytics plugin is actually using the analytics endpoint provided by GoCD, and that endpoint is open, and people can write their own analytics dashboards, which integrate into GoCD just as well as the one that we saw. So it will show up on GoCD, it will be embedded there, you can click on it, and you can, your plugin will get information about what people did and all the information around that, and you can definitely show your dashboards as well. But that's the advantage of it being open source. The actual endpoints for the analytics plugins and the notification plugins or pollers or any of those, they're all open. There are a lot of open source plugins as well, which people have written, and you can write your own. There is a small thing that I want to mention quickly about GoCD's philosophy regarding plugins. If you've used something like Jenkins, you know that Jenkins in its core is really, really simple. There is almost nothing there. Even something like Git support has to come through a plugin. You might or might not notice it depending on how you install it, but even something as simple as that has to come from a plugin, which in certain cases causes problems. When you want to upgrade, you're never really sure whether an upgrade will make sure that all of your plugins are working and so on. GoCD adheres more to the philosophy mentioned in the CD book. I alluded to this a little earlier, where scripts which are user-written scripts are the preferred model, where instead of depending on plugins, you depend on scripts that you have written yourself so that you know exactly how deployment happens and not outsourced to a plugin as such. So that even if you want to move tools and switch from one CI system or CD system to another, it's really easy to do that because they're all shells for calling out to your scripts. So you version all of those scripts, you put them all in configuration control, you can see how everything works, and you don't really depend on the tool, that CI or CD tool, to be how you do, to be the only way that you do deployments. But yeah, you can definitely write plugins as
well. Okay, it looks like that is all of our questions. We have 4 more minutes in our scheduled time. So if anybody was waiting until the last moment to post your question, you can definitely do that now. Again, if you didn't complete the poll, it's really useful for us to get your feedback. So just take a couple seconds, click through those 3 questions, let us know what you think. If there are questions that you don't want to ask in the Q&A, you can also get in touch with us. So again, go to our website, gocd.org, and you'll see ways to connect with us there. And we'll be happy to talk to you either now or some point in the future about metrics, continuous delivery, GoCD.
Okay, I don't think we're going to get any more questions, so I'll just go ahead and say thank you all for joining today. We'll do this webinar again for folks in Europe and Asia Pacific. So if you're interested in attending another version or inviting your colleagues, keep your eyes peeled, and there'll be an announcement about that shortly. And of course, if you're interested in learning more about Go, please visit gocd.org. Thank you all very much.
Thank you.
Thank you.